Right, I want to start with something that always strikes me about the geometric marks left behind by our distant ancestors. If you look at archaeological finds from Homo erectus, Neanderthals, and of course Homo sapiens, all sorts of line engravings, hash marks, grids, zigzags, they're astonishingly consistent in form. These are found on ochre pieces from Blombos Cave in South Africa, engravings from Diepkloof, even pieces created by Neanderthals in Europe, going back tens of thousands of years, sometimes more. It's peculiar, isn't it, that different hominins across such a staggering time span would gravitate toward the same basic patterns. If you heard our previous episode, we talked about Derek Hodgson's neurovisual resonance theory, which basically says our brains are wired to notice and enjoy these patterns, not because they mean something, but because they fit the way our visual cortex likes to process the world. This theory stands in contrast to the old, almost romantic idea that these marks were laden with symbolism or secret codes. It's actually about the most fundamental wiring in our brains. You see, these geometric lines and repetitions, grids, angles, even simple crosshatch marks show up well before the earliest drawings of animals or humans, which pop up in places like Europe around 40,000 years ago. And just as a quick personal note, I remember seeing an illustration of that 77,000-year-old Blombos ochre engraving for the first time, and honestly, I had this weird moment of recognition. It's almost as if my brain couldn't help but find the symmetry pleasing, the rhythm of the lines somehow familiar, even though the engraver lived so many millennia ago. I suppose it's a reminder that our attraction to these marks might be much deeper and more universal than we tend to admit. So the big question is, why did the urge to create grids and zigzags emerge well before drawing any kind of animal or human figure? According to neurovisual resonance theory, and I should add, this isn't just speculation, our early visual cortex is built to respond to recurring shapes, especially those that are common in the environment. The theory proposes that the oldest geometric patterns weren't meant to symbolize anything. They just echoed the basic structure of the brain itself. All right, let's dig a bit deeper into how our brain recognizes, lines. There's fascinating research using neuroscanning where researchers have looked at exactly which parts of our brain light up when we see these ancient marks. Areas V1 and V2 in the visual cortex are sort of like the brain's first responders, especially tuned to pick up very simple configurations. L shapes, T intersections, X junctions. These aren't just abstractions, they're literally everywhere, both in natural environments and in the earliest archaeological patterns made by humans and our relatives. What's clever is that these geometric primitives, as they're called, are the building blocks not just for art, but for our ability to recognize objects and make tools. In fact, there's reason to think they provided a kind of scaffolding, a perceptual structure on which early mark-making was built. These simple features, processed by specialized neurons, are ideal for detecting edges, shapes, and ultimately for recognizing what's in front of us. To put it another way, our ancestors weren't just doodling. Their brains sought out and replicated the most salient, repeatable forms their visual system was tuned to detect. There's a brilliant case study that really brings this idea home. Neuroscientists like Stanislas Dehaene and others have shown that the same kinds of line junctions, L, T, and X, are the essential foundation not only for cave engravings, but for global writing systems. Letters, scripts, signs, they're all ultimately constructed from these primitives. That's why the resemblance between ancient patterns and letter-like forms is so striking. Even baboons, bizarrely enough, can learn to discriminate real English words from non-words just using these visual cues, without understanding the meaning, as Granger et al. Showed. It's a testament to how the early visual cortex is universally primed for these shapes. So when you notice geometric engravings, you're not just looking at cultural quirks. You're seeing the fundamental language of the visual brain made material, repeatedly across continents and across species. The reason these patterns crop up again and again isn't cultural inheritance necessarily, but the way our brains, and even those of our evolutionary cousins, are built to filter and focus on visually useful information. This brings us to one of the big debates. When do marks become more than marks? The neuronal recycling model offers a clue. Basically, as written language evolved, areas of the brain originally developed for object and face recognition were gradually repurposed or recycled for reading and symbolic thinking. This didn't happen overnight. It probably occurred in fits and starts, depending on practice and cultural context. There's some truly eye-opening neuroimaging work around this. Now, here's where it gets contentious. Some studies, like Mellett and colleagues in 2018, suggest that viewing these ancient marks activates the higher semantic processing regions, implying that they might be symbolic, maybe even intentional social signals. But Thailand and others, looking at different types of marks using more experimental setups, found that the patterns often weren't distinctive enough to serve as consistent symbolic signals. Instead, they might have triggered a sort of proto-aesthetic or baseline pre-symbolic appreciation, driven by how the early visual cortex processes pattern and repetition. And here's the fascinating wrinkle. Much of this pattern attraction happens pre-consciously. The marks might prime the brain, drawing conscious attention only after a kind of tug-of-war between multiple representations in early visual cortex. In other words, our brains might be wired to notice and gravitate toward these features, even without any conscious intention to communicate meaning. It's not until much later, and probably after lots of practice, as with literacy, that these areas can be fully recruited for elaborate symbolic purposes, like reading or formal writing systems. I find myself wondering, could it be that our enduring fascination with patterns, rather than the deliberate desire to say something, was the real catalyst for symbolic culture? Studies on illiterate adults and even baboon experiments hint that the perceptual roots of geometric mark-making are deeper than symbolic intention alone. Maybe that's the story. A brain primed to resonate with certain shapes, laying the foundation for the later explosion of art, symbol, and written language.